Welcome to Wings of Arrow Advanced Education and Research Organization. To know more, visit our official web page www.wingsofarrow.in. Hi guys, today we are going to see a topic based on Introduction to Buckling. So before we start, what is meant by buckling? Theoretically, buckling is a structural instability caused due to sudden deflection of any structures subjected to compressive stress and leads to an failure mode. The aircraft. The aircraft is made up of an airframe, specifically fuselage, nacelle, cowling, fairings, airfoil, and landing gears. These airframes are the basic structure of an aircraft. This is designed to withstand all the aerodynamic forces as well as all stresses imposed by the structure. So we can know that the aircraft wings are the major lift load carrying members in the airframe structure. So in this case, what happened on the lower curvature, we have a high pressure, and upper curvature we have a low pressure. So we can say, as per the survey, 80% of the lift load will be carried by the wing structure in an aircraft. So because of this lift load, the wings will be bent upwards during flight, as you can see in the figure. Due to this action, makes the upper skin of the wing to experience compression, which is shown in red color, and the lower skin in tension. We can see a demo of this phenomenon. So here in this case, what is happening? The upper surface is getting compression and the lower surface in undergoing tension. So due to this, you can see a skin surface is forming a wrinkling over the upper surface. This causes a phenomenon called buckling. The sudden failure of a material component due to structural instability, which is often called as buckling. This buckling will reduce the load carrying capacity and the component may fall below the design load limit. What is meant by design load limit? We have studied a factor called Venn diagram. So that factor will get reduced. So for a structure to be safe against buckling, we should keep a note of it. The buckling factor should be greater than 1. To analyze in any software, we have to keep in mind that buckling factor should be less than 1, then only there will be a structural failure due to buckling. Please make a note of it. This is a Venn diagram. So in this Venn diagram, we can see after we reach the corner velocity, beyond that, if we increase the load factor with respect to the increase in velocity, it will cause unstructural damage and it can cause due to buckling, a sudden failure due to buckling. So when the wing subjected to compressive loads tends to buckle, undergoing a sudden large lateral deformation. Such phenomena is called as buckling. So this buckling could occur before the material fails due to high stresses. A large proportions of an aircraft structure comprise of thin wave structures. So we have to keep in mind or carefully design while designing the skin material of an aircraft, because thin skin are more prone to buckle. So to increase the strength of the material, we use stiffness. So in other words, mathematically, we are enhancing the second moment of inertia. What is meant by second moment of inertia? That means when we apply a load onto a material, it has a capacity to resist or twist or bend. So this is an example. You can see the aircraft tends to buckle due to a compressive load across the fuselage structure. And this is another figure applications which causes a bottom part of the fuselage of a Cessna aircraft. So this is a software, the Sky Sieve Structural 3D can perform the buckling analysis. This helps because other software they are the linear static analysis software. They will not detect the failure due to buckling. So for this reason, if you want to analyze a buckling, so you need to perform this separately, because this software will give you the lowest or least buckling factor of the structure.
Thank you for watching this video. If you have further inquiry or requested video, drop down to our mail wingsofarrow@gmail.com. Don't forget to subscribe for more updates. For the time being, take care, stay blessed, inspired and fly high.